All right, so let me write down the answers here. A is 9, and this is -5 to -3, and 0 to 2. All right, part C. Yes, we are going to take the derivative. It is going to require the quotient rule. So let's go ahead and jump into that. And this is why we learned those general rules for quotient and product and chain and all that, because this is how they love to use them. So we're trying to find h prime of 3. So let's start with just h prime of x. So it is low d high. So 5x times g prime of x minus high d low g of x times 5 all over low squared. So 5x in parentheses squared. Now, there's not really any, there is a little bit of simplifying that we could do. Let's look at that. In the numerator, both terms have a 5. Go ahead and factor out that 5. Because this is calculator inactive, so you want to make your calculations as easy on yourself as you possibly can. In the denominator, 5x squared is equal to 25x squared. You got to square the 5 and square the x. So what we can do is we can simplify the 5 over the 25, and that leaves us with a 5x squared in the denominator. So now we can plug in our 3. H prime of 3 is equal to 3 times g prime of 3 minus g of 3 over 5 times 3 squared. Okay, so let's see here. G prime of 3. We are looking at the graph of f. Let's remind ourselves, this was similar to the problem that we had yesterday. G is equal to the integral of f. So if we take the derivative of both sides of that expression, that means that g prime is equal to f. F is equal to g prime. So if we want g prime of 3, technically we're looking at g prime. So we just need to find 3 on our graph, and it has a y value of -2. If you're unsure about that, look at the slope of that line. Look at what the rise over the run is. Use this point here on the axis and this point right here. You go up 4 and over 2, so it has a slope of 2. So that is indeed at -2. So g prime of 3 is -2. G of 3, we found that in part A. So here's an example of where they're going to grade with your answer. So say for some reason you messed up on part A, you miscalculated that, or you didn't think about it the right way, they will take your answer from part A and they will grade with you in part C. So you can get full credit for C without necessarily getting full credit for A. And in the denominator, we've got 5 times 9, so we've got 45. So we've got -6 minus 9, that's -15 over 45, so it is -1/3. So they give you 2 points for your h prime of x expression. So I'm assuming there's a little bit of leeway in the quotient rule there. If you mess something up, they'll give you 1 out of the 2 points as opposed to necessarily the whole 2 points. And then you get 1 point for your final answer of -1/3. All right, part D is kind of similar to this one, actually. They give you another function, and they say find the slope of the line tangent to the graph. So slope of the line tangent to the graph should make you think derivative. Right, so we need to take the derivative of this p of x function. So p prime of x is equal to, this is a chain rule. This is a chain rule because we have f and we have something inside of f. So chain rule says take the derivative of the outside, keep the inside the same, times the derivative of the inside. So we've got f prime of x squared minus x times 2x minus 1. They want us to find, it doesn't say find the equation of the tangent line, just the slope of the tangent line. So we just need p prime of -1. We don't have to take it further than this. -1 squared is +1 minus a -1 times 2 times -1 minus 1. So we have f prime of 2 times -2 minus 1, so -3. So f prime of 2 is going to come from our graph. Let's see here. We are looking at f. So f prime would be the slope of the line at 2. So the slope of the line here at 2 is that slope that I just calculated in the last part. It's a slope of -2. Rise over run, so it's -2. So -2 times the -3 is +6. So this is the slope of f. Oops. Okay, so on these questions, they really, really love testing. Do you understand the connections between functions, their derivatives, their second derivatives, and integrals? How do they all fit in together, and how can we get all that information from one single graph? So if you're not using slopes of tangent lines, if you're not using areas under the curve or something like that on one of these problems, you're probably missing part of the point.